Hello and welcome, everyone. My name is Mark Henry. I'm a senior engineer with opEvents North American office located in Charlotte, North Carolina. Today, we're going to be talking about a subject which is really very near and dear to my heart, which is advanced diagnostics and network automation with opEvents. So a little bit of quick housekeeping for you. If you're in the live GoToWebinar today, and I see we've got a very large crowd, we will be sending you a follow-on email with a link to this recording on the GoToWebinar website. However, if you're viewing this on YouTube, or if you're viewing this on the augmentic.com website, appreciate you being here. Please check out our live webinars. Happy to add you into future ones. For those of you in the GoToWebinar, please feel free to submit your questions at any time. We'll do a Q&A throughout. I'll keep an eye on both the chat window and the questions panel. And so if you have any questions, submit them during the presentation. Happy to add them through and respond to them as quickly as we can. Finally, if you're in the live GoToWebinar meeting, when you exit, whether at the end of the webinar or if you leave early for whatever reason, you'll be presented with a very short exit survey. It's only 3 questions. They're multiple choice. I promise you it's really quick to answer. But please take a moment of your time, complete the exit survey. It does help us become better presenters, and it does help opEvents determine what types of webinars to do in the future. All right, so focusing in on today, right? The concept is you can't just wait for an alarm to go off and then respond to it, especially if you're just running a Monday through Friday working hours type network operations team. What happens after hours? You might have somebody who's on call, who has a pager, who has a cell phone, who gets woken up at 2 o'clock in the morning because events are happening on the network. And if you have to wait for that person to wake up or to prioritize the event, log in, dig into the problem, try to see what's going on, in many cases, valuable information about the event has been lost. Too much time has passed. The engineer may not be able to find the types of information he needs, or the event might have closed already, and so he can't troubleshoot it and capture troubleshooting information to help prevent that type of event from happening in the future. So instead of just waiting for someone to respond to an event, to an alarm, what we want to be able to do is we want to be able to automate 2 types of things. The first is what we call troubleshooting, right? The concept that you're going to gather as much information as you can about the event, about the equipment, about the state of the network, the state of the device, the state of the interface. As you can, you're going to gather that troubleshooting information and store it with the event. And then depending on what kind of event it is, you may even take proactive action. You may restart a service. You may restart a server. You may reroute traffic on your network, change your routing tables on your routers. So there's lots of things that you can do. Basically, it just comes down to if you can execute it from a Linux command line, whether that's something like just a Linux command, like a traceroute, or that's a bash script or a PHP script or a Ruby on Rails script or a Perl script or any kind of script that you can run from a Linux command line, then you can automate it with opEvents, and you can add it in as a response to specific events. So today what we're going to do is we're going to touch on the 4 steps needed to create a robust network automation, right? We're going to talk about how to quickly and easily build these automations. And then we're going to talk briefly about the mental shift and the processes needed to go from kind of a reactive to a proactive response methodology in your team. I always like to marry these presentations back to Gartner's IT Service Management Maturity Model. You can see here the darkened steps at each of the levels. So we're supporting level 1, level 2, level 3, and well into level 4 as well by doing automated troubleshooting and response. There are 2 solutions that are part of this package today. The core is NMIS, is opEvents NMIS, which is our fault and performance monitoring solution. And then sitting on top of that is opEvents, which handles the advanced event management and response. So a few references for everyone. You of course have the opMantic wiki. The opEvents homepage is a great place to start. There's a couple of links here for how to set up email notifications and actions, and then how to do event actions and escalations as well. There are many more pages here. You'll see later on in the presentation, I try to put links to specific wiki pages on specific topic areas. You also have the opMantic community questions board. So feel free to come there, post your question. An opMantic engineer or one of our senior members will come out, answer your question for you, help you out. If you are a supported customer, please, of course, email your questions to support@opmantic.com. And if you'd like to know more about how to license opEvents, feel free to reach out to our sales group at USA@opmantic.com. And if you're outside of North America, the US and Canada area, our sales team here at the US will be happy to do an introduction to our Latin American, our Asia Pac, or our EMEA teams. All right, so a fast background on opEvents. Today we're going to be focusing in primarily on what are called event actions, which are how to take proactive response to events that are being handled by opEvents. But before we can get to that, let's just lay a little bit of groundwork. So opEvents is one of opMantic's commercially licensed products. You'll see here that you have NMIS right in the center. It's handling service monitoring, SNMP and WMI polling. It's also parsing out SNMP traps, and it's sending all of those events over to opEvents. opEvents can also handle syslog parsing. So if you're looking for something that will not just archive your syslogs and store them somewhere, but will actually parse out your syslogs, generate events from it, and then take action, that's opEvents. opEvents will do that part. All right. So opEvents. opEvents is an advanced fault management and operational automation system. What it does is it actually builds on NMIS's built-in thresholding escalation notification system. It does things like whitelisting, blacklisting, handles event correlation, deduplication, event storms, and again, importantly, it can take proactive response or proactive action to events. If you're looking at the way events occur, or are processed rather in opEvents, it starts by applying this archive list, applying a black list and then a white list. So what events should never be dealt with, what events should always be dealt with. We then correlate events into outages. So we do event correlation. We deduplicate event. So we're dealing with event storms, event flaps. We will then determine the priority of the event, conduct actions, and that's why this panel is in red. That's the piece we're going to be talking about in detail today. And then we do escalations. For those of you who are following along today in the presentation, by the way, if you check out the GoToWebinar handouts panel, you can download this presentation in PDF format. For those of you who are on YouTube, please come to opmantic.com, go to the blog section and find this presentation. You'll find the PDF there. And of course, if you're already on opmantic.com watching this presentation, you should have a downloadable version of this available to you. All right. So basic goals, really, that should drive intelligent event fault management. The concept that you're going to manage measurement and thresholding intelligently. So you're only going to collect on things you care about. You're going to generate alarms on things that you're going to take action on. You're then going to capture event details from all the events that meet that criteria. You're going to assign priority based on measured impact. So what's the impact to the business? Does it really matter if a specific server goes down at 2 a.m. in the morning? It might not. It might simply be a backup device. It might be a device that's only in testing or is only for development, and the team doesn't need it until the next day. So you're going to do measured impact, and you're going to assign a priority to that event based on the impact to the business. The next thing you're going to do is you're going to conduct any kind of troubleshooting or remediation automatically. So you want to do as much of that as you can before an engineer has to touch a keyboard. And finally, you're going to alert the correct resource in a timely manner. Again, if you're measuring a parameter, if you're setting a threshold or an alarm on it, And then if you're capturing information and you're responding to it, you may not have to notify someone that you've done that, or you may tell them in the morning, or you may generate a ticket but not necessarily wake somebody up, or you may only take action and notify people Monday through Friday, 8 to 5, or whatever. So, each of these steps drives the process that feeds into what you're going to do. So we talked about the concept of network automation, where you can monitor those events and then take some kind of proactive action, right? And again, what I mean by that is troubleshooting, repairs, remediation, whatever phrase you want to use for it. But to do that, it's 4 simple steps. And it really is very, very simple when you break it down like this. We've done these types of kind of teamwork group exercises with our clients, where our professional services group will sit down and we'll say, okay, give us the top 3 events that you've dealt with over the past week. And we'll list those out on the whiteboard. And we'll say, okay, now, what were the top 3 events last week? The top 3 things that really caused problems in your event, in your network. And those could be events, again, that happen every day, once a week, once a month, but are really service impacting. So you create these lists, and then you find commonality. You say, okay, what are really the top 3 or 4 or 5 or 10 events that happen on your network, and let's address those things. And so you start one at a time. And we've got a little worksheet that we do, where we put a title for the event, we put the type of event, we identify what types of equipment generate that event, we identify what the impact is to the business, and then we list the steps that an engineer would take, again, both troubleshooting and remediative, when the issue occurs. So for example, if you had a node down, if you got an email or a ticket today that said that a specific server in the system was down, what is the troubleshooting that you would do, right? So would you open up a terminal window and try to ping the device? Would you do a trace route to the device? Would you do an MTR? Would you open up a command line window and try to SSH to the device? Would you SSH to the device and then try to execute a couple of CLI commands to gather information about a router, for example? Would you open up PuTTY and try to check the device? So what are the things that you would do? So we then write down those lists, those steps, again, in the order the engineer would do it. And you want to try to include several engineers, both senior engineers and junior engineers, in that kind of a discussion, because the senior guys are going to take some shortcuts. They're going to use some of their experience in both networking in general, but also specifically in the architecture of the network that they're talking about, and the types of equipment and the types of events that they see, where junior people might be taking a slightly different route. So you want to include a couple of different people from different areas of experience in that discussion to create that list. Then you want to identify how those steps can be automated. So if someone is using, let's say, PuTTY to remote into a device, can you simply do an SSH session at the terminal, right? So can you go from the opEvents server, which is a Linux server, and go from a command line there and execute those commands directly from the Linux command line? And then what would those look like? What would those commands look like? What would all of the arguments look like? And then what would the results, the expected results, look like from that command as well? So identify all those steps, then identify how those steps can be automated, and then script an action to respond to that event. Now, it sounds simple, but once you get to step 4, you go back to step 1 and you work on the next event in the list, and you keep going this way until you've created actions for all of the primary events that you have, all the ones that are major service impacting, the ones that cost you money, the ones that impact worker time or worker ability to service the client, the ones that result in lost revenue streams, the ones that eat up network bandwidth or slow down performance across the network. So you continue to work on this, and this is one of those exercises where you might put a large amount of concerted effort up front to identify maybe the top 5 or 10 events and address them and really get them automated and working the way you want, and then let the system settle out over a week, a month, see how it's working, and then go back and revisit what are the top events now. After 30 days of operation, what are the top events that are occurring now? They might be very different from the ones that occurred when the system was first stood up. So we're going to go quickly through a little bit of background about opEvents, and then we're going to, in order to get us into EventActions. So the first piece is where are all these rules kept? So if opEvents does whitelisting, blacklisting, and archiving, where are the rules for that? Well, it's in a text file called eventListRules.nmis. Correlation and suppression rules are all in eventRules.nmis, and policies, actions, and escalations are all in EventActions.nmis. And we're going to be looking specifically at EventActions.nmis today. So event correlation, again, correlations are all time-based. It's the concept, for example, that if multiple devices at one location all go down within a given amount of time, that you would roll that up from individual node down or device down events into a location outage. There's more information here at the link at the bottom of the screen. I'm going to move forward. These are what the rules look like for event correlation. We do ship with all of these rules pre-built in. You can comment these rules out if you don't like them, if you don't like the way that they work. Many of them are stateful, meaning that for example, when a location outage occurs, you can actually have a location outage clear event to statefully clear out that location outage as well. Not all of these can be stateful. So it would be good for you to familiarize yourself with that file, the correlation rules that are built in, and then again, internally just have that kind of engineering architecture discussion and determine which correlation rules, if any, you want to have in place. It is important to understand with correlation rules, though, that the individual events still exist, and event actions can take place to those individual events, and you can also run event actions against that correlated event. So if you had multiple events at a specific location go down that created a location outage, those node down events could have their own escalation policies and also their own event actions happening, but also you could have event actions happening for the location outage itself. So event actions, these are the things that are actually proactively reaching out and doing something. So again, these are all stored in the script section of the EventActions.nmis file. We're going to take a look at that in just a moment. Actions are extremely flexible, so they can be called from any section within the event actions file. So there's a policy section where you have if then else rules, where you're doing testing if if the event is a node down and the event group is VIP customers and it is after hours, then do these things. And again, actions can do anything from troubleshooting to remediative in nature. If you can conceive it, if you could execute it from a Linux command line, if you could write a script that can be executed from a Linux command line, if you can execute a script that could call out to something else to do what you want it to do, you can do all that. So here are some examples of some scripts. If you download the Automatic virtual machine, the Automatic VM, sometimes called the Automatic appliance, the EventActions.nmis file comes with these actions pre-built in it. But it's things like if you have a proactive CPU event on a Cisco device, run show processes CPU sorted and show IP flow top talkers, and then take the results of those and attach them to the ticket. Down in the bottom left-hand corner, you'll see there's an example where we're doing a couple comparisons. We're saying if the role of the device is distribution and it's a stateful event BGP neighbor, then ping the node host, ping the event element, then run show IP BGP, show IP BGP summary, and show IP route summary. Those last three, in fact, any of these ones that are actually a Cisco kind of CLI interface command, actually requires opconfig as well in order to execute. If you don't have opconfig, you could actually write your own script to connect to the device and execute the CLI command, but that'd be a little more heavy lifting. I like to leverage technology to my benefit. So what I'm going to do is I'm going to switch over quickly. Let's take a look at what this actually looks like in action. So I have here opEvents on my demo server. We're going to take a look at this. We have a ticket here, or we have an event, proactive interface error input packets. This is on one of our little B&E lab virtual routers. So you can see the event here in the left-hand side, proactive interface error input packets. It was on the interface Ethernet 1/2. Bandwidth is 10. The threshold here is 0.5, and the current value is 8.5333330. So there's a lot that's going on here, a lot of information. Down here in the middle of the page, you'll see actions taken for the event. And this is read from the bottom to the top in time. So the most recent actions are at the top of this list. You'll see the most recent action here is acknowledged because it's a stateful event and the state changed. And so the event cleared itself, it acknowledged itself. But you'll see that there were two scripts here that ran. And you can see down at the bottom, the output from those scripts are connections to opconfig. So what's actually happened here is we've seen that there are errors happening on the input packet side of this interface. We're seeing a high error rate on that. It's exceeding our threshold. In response to those errors on that interface, we're executing two scripts. And what those scripts are actually doing is changing the prioritization of the routing tables on those two routers and forcing traffic to change its routing throughout our network. So this interface is not doing well. It's got a lot of errors on the interface, and we're just going to be proactive, and the system's going to reroute traffic immediately. Let's take a look at another one. So now this one happens to be SNMP down. Now this happens to be SNMP down on the actual demo server itself. So no response from remote host 127.0.0.1, outage current true. So if we come down and we look at the list of actions, again, reading from the bottom of the top, so the priority says add 3 to the priority. The new priority is now 6. Now, an outage is current for this event. So this device is actually marked for being in outage at the moment. So someone's put this server into an outage mode. We've adjusted the priority after that. So devices that are in outage have a lower priority than devices that are out of outage. We've found that it is an outage. That's great. But we've still, even though the event happened and even though the device is in outage, we've gone ahead and we've still run some troubleshooting. And you'll see here, for example, we've run a ping node and we've run a traceroute node. And if we look down here at the bottom, you'll see traceroute node, traceroute to localhost. So this is actually the output of that command. So we're capturing that output, and because this is actually the demo server, it's doing a traceroute to itself, which is kind of crazy. It's important to note that these commands are being executed by the actual polling server, the NMIS polling server that's responsible for polling and communicating with that device. So these commands are being executed from that server to that device. So I'm literally running a traceroute from the polling server to the device that's reporting the outage. In this case, it happens to be the polling server itself. So the traceroute kind of just circles back around. And I also ran a ping node. Now, there are certainly other things that could be done. You might want to do an MTR rather than a traceroute. Again, that's why it's an important exercise to sit down and work through that list of the top events, and then what are the actions that are taken? What is the troubleshooting that an engineer does? And then what do you do with that information? All right, let's go back to PowerPoint for a minute. So in addition to being able to take action, you can also do event escalations. So you can actually notify someone. You might do things at certain times. Escalations are all time-based. Time starts when the rule is matched. So there's a policy check inside the EventActions.nms file. You might say, if this and that, then do something. And part of that do something might be escalate and tell people that something has happened. Those escalations, that escalation policy that gets called, will run as long as the parameters that call that escalation are in effect. So if you did one comparison, if node down, then do this. Once that node comes back up, the escalation stops. The escalation policy stops because it's no longer needed to be enforced because the parameters that cause that escalation no longer exist. All right, now let's take a look at what these look like. So we talked about the concept of escalation policies. So the opening section of EventActions.nms is the policy section. And this is really nothing more than an if this, then do something. So I'm going to scroll down to one here. So you can see, for example, we have if event.node equals BNE lab RR1 and event element equals Ethernet 1/2 and event equals proactive interface error input packet. So we're checking three things. We want to be really, really specific. Is it this device and this interface and this event? Then, in this example, run these two scripts. So I'm calling two scripts. These are actually stored in the script section of this file. So just like this is the policy section, down at the bottom of this file, and I'm going to scroll down pretty quickly here, there's a script section of this file. And you can see there are all kinds of scripts that are in here. So for example, there's the MTR node, there's the trace route node that we looked at a moment ago with that device down. Here's the ping node. And of course, you can change these arguments, you can change these pieces. The output equals save simply means that the results of this should be saved into the event. Ping neighbor, and then you can see here there are some troubleshooting ones here that actually call out to opconfig. So this one's actually using the opconfig API. So it's the command line interface for opconfig. So those would all require, of course, you to have opconfig licensed, and for those devices to be in opconfig and licensed in opconfig as well. But here's that. Here are those two scripts: BNE Lab P2 FAOO route not, and BNE Lab RR1 E12 route not. And so this one is calling. This one's actually calling out to the opconfig CLI, and it's pushing a configuration set that's actually stored on this server. So even though it's a script that's calling to opconfig and pushing a set of configuration standards out to it. All right, so let's go back up. We're going to go back up to the policy section again. Everything starts at the policy section. And many times when I'm going through these types of event actions, because there's so many moving parts, people will kind of get overwhelmed at a moment. And so what I want to really encourage everyone to do is to sit down with a blank piece of paper or a blank whiteboard, pick one event, just draw a horizontal line across that whiteboard or that piece of paper. That's your timeline. Draw a vertical line on the left-hand side. That's the moment the event occurs. And then start putting hash marks and writing in things that you want to have happen along that timeline. And the further from the left to the right you go, that's more time, that's more seconds of time. So you might start and say, at time 0, when the event occurs, I really don't want to do anything. Or maybe I want to write this event out to a log file. I want to store the event for future posterity's sake. And maybe I want to run a couple of scripts like an MTR, and I want to run a custom script that I wrote myself, I want to run that when the event occurs, but I don't want to wake anybody up for about 15 minutes. And so I can actually, once you visualize that, once you visualize that timeline, you draw that horizontal line on that piece of paper on that whiteboard, and you start putting actions out, then it starts building out the event actions policies much easier, because you'll be able to say, okay, this is the event, and these are the parameters I need to capture for that event. And in the example of the event down here, where we are doing an example of rerouting traffic on this router, we're matching 3 different things. Is it a specific device, specific interface, specific type of event? And then once you identify what things have to be compared, you can create your policy. Then you can start adding in the things that you want to do. So in this example, we're calling a script. In the example just before it, we're changing the priority of an event to a priority 3. Next to it, we're actually adding a note. We're adding a notation that'll show up in the event actions details window called event processing notes. So we're going to have a notation there where somebody can look and go, oh, outage current for this event. Oh, okay. All right. This device is in outage right now. So let's take a look at a few more comparisons, a few more of these policies. So node.role type equals core. Event.event is similar to or contains down. So that could be SNMP down, that could be node down, that could be interface down. So there's a lot of events that will include the word down. So in this case, we're simply saying if the device has a role type of core and something is down, or the event includes the word down in it, add 3 to the priority. And then we're going to continue going. So role type equals distribution, and event, again, contains the word down, priority +2. Node model equals Cisco router, and event.event equals proactive CPU. Then priority +2, script.iOS CPU router. So we're doing all kinds of things. We're actually looking to see what kind of device this is. In this case, we're actually looking to see which model, which NMIS model is being used to collect information on this. Now, generally speaking, I might not use this route in this example. It's done here just for clarity's sake, keeping in mind that you need to know both the manufacturer and model of the device to know which types of CLI commands you can issue. Now, there are hourly and troubleshooting CLI commands that can be called in opconfig. That's a little outside the scope of this session today, but just know that, again, you can break this down by maybe node type equals router and event equals proactive CPU, and then you could determine after that point a little more granularly using opconfig what type of device it is, and then be able to execute the right CLI commands against it. So lots of different examples here in the policy window. Again, all these ones that call out to opconfig requires opconfig to be installed, to be licensed, and the devices that it would be collecting from also to be set up inside opconfig and licensed in opconfig. Keeping in mind, of course, also that both opEvents and opconfig come with a free 20 device license for life. So whether you're setting this up in a lab environment, or you have a very small business network, or if you're setting it up in your home environment, I know most of the engineers here at Opmantic have our solutions actually running in their homes, helping to monitor their home environment, their Internet of Things, and taking actions, turning on lights, turning on pumps, pools, adjusting power, all those types of things. So there's an awful lot that you can do here, and a lot of automation that can be done. Few more examples on matching here. Node.customer equals pack. So notice that this whole set of rules will only be evaluated if the device in question is assigned to the customer pack. So if it's assigned to any other customer, it might be assigned to Opmantic, it might be assigned to sales, it might be assigned to Coca-Cola. None of these would fire. These will only be evaluated if the customer is equal to pack. And there's a couple of really good examples here. So node type includes the words distribution or core or access. So if either of those three are in the role type and the event is a node down, then do a ping node. Now notice on the next one down, we were just looking at distribution and core with SNMP down, and then do a ping node. So we've changed the rules just a little bit here. Here we've done a kind of an odd change. We've said if role type includes a period, so if the role type has a period in it, and the event is a service down, run a script.ping node. So there are certain roles that'll come back, certain service monitors that'll include a period in them. And so you can actually do a comparison just on the punctuation, if the punctuation exists in that field. There's lots and lots of examples that are here. If you're really looking to do event actions, take a look, download the Automatic VM, take a look at the EventActions.nmis file. Really try to absorb how this is built. Read the wiki pages that are associated with creating the policies and also creating the scripts. The last piece of the puzzle, beyond the policies, the scripts, are the escalations. So I'm going to scroll all the way down to the bottom of the file now. The escalate section is at the bottom of the file. Now the escalations are pretty straightforward. You provide the escalation a name. Now this escalation happens to be weekday. It could very well be George. It could be end of week. It could be after hours. It could be whatever you want to name it. But the name and the section title need to be the same. Then there's a section of ifs, and basically these are your testing things. So you can create different escalation policies based on the priority of an event for specific days of the week. So for example, you can see that this one's marked as weekday. This one's marked as Monday, Tuesday, Wednesday, Thursday, Friday. It's for anything with a priority that is greater than or equal to 0 that starts between 9 a.m. and ends at 19 p.m. So this is military time, 24-hour clock. Time is local to the server, not your workstation, not the browser, but the server that this is running on, of course. So from 9 a.m. in the morning till 7 p.m. at night. And then these are the rules that will be executed. These are the things that are being done. So 60 seconds or 1 minute after this escalation policy gets called, you're going to write out a message, an XMPP message to operations. Then you're going to call the script ping node. So interesting here that we're doing a little bit of messaging to operations, and we're doing a script. We're executing a script from within the escalation section. You can actually call inside the escalation section anything you want to call other than another escalation. So I cannot call an escalation from within an escalation. However, I could from inside inside a script, or from within inside the if then else statements at the top of the file, I could call multiple escalations. So I can call both escalate weekday and escalate after hours at the same time. And then the system will simply look and say, oh, it's 2 a.m. in the morning on a Saturday. The weekday escalation doesn't fire. This if would fail at 2 a.m. on a Saturday because it doesn't fall within the days or the starting and end time. However, because I called the after hours escalation, as long as the priority was greater than or equal to 5, and it was between 1900 and 9 a.m., this would fire. Now, I could also do one on the weekend as well. So you'll notice that we've got example escalations here for weekday, after hours, and weekend with slightly different pathways, different things that are happening here. So each of these operations that are happening, for example, we're at time 300, so 300 seconds in to this event. If the event is still active, if the event has not been acknowledged, or if it was a stateful event and didn't clear, then it's going to generate an email to the contact labeled operations. So we have a contact.nmis file, contains all your list of contacts. It'll actually pull the contact information and generate an email for that person. And that contact can actually have a preferred method or template for communication, for email communication. That could be a very very convoluted format template with lots and lots of data in it, or it could be a very, very short template. So if you wanted to perhaps generate a SMS text message, you might want to create a very, very short one that simply says, main server is down, wake up. All right, let's switch back over to PowerPoint for a moment. So email notifications, again, the rules are defined in EventActions, right? opcommon.nmis sets up the global email parameters. So your email server, your port number, your passwords are all inside opcommon.nmis. Contacts.nmis is normally symlinked from the /omk/conf folder into the nmis8 conf folder, but they can be separate files if you want to. They can absolutely be separate, no problem at all. And the event emails.nmis file defines the email templates to be used for a particular contact. All right, that concludes this whirlwind overview of network automation and event response. If you have any questions at all, please don't hesitate. Feel free to shoot me an email. It's markh, that's MARKH, at opmentech.com. That's also my cell phone number there, 207-951-2428. Feel free to give me a ring. Happy to get on the phone with you, do a screen share, talk about our products, talk about your challenges and solutions, understand where we have some overlap and some synergy, and see if we can help you out. Until next time, this is Mark Henry, wishing you all a happy and safe day.